Good morning again, dear students. This is Mr. Abdurrahman Dawi with another video recording to solve one of the problems has been sent by one of your friends and the students. In this problem, we are dealing with the even and the odd theories. How to prove that the following. He said the question, prove that the product of any two odd numbers is always odd. What is the idea? It's like that the question is asking you. We know that when we multiply 1 by 1, we get 1. When we multiply 3 by 3, which is actually both of them are odd numbers, we get 9. If I multiply, for example, 5 by 7, I get 35. So as you can see, the result is always an odd number. So right now he wants you to prove that algebraically. Okay. So before we talk about anything, I'm gonna just mention the following. N, it could be anything, it could be any integer. And as you can see, these numbers, we refer to them as even numbers. While if I'm dealing with these, I'm gonna try a different coding. 1, 3, 5, 7, 9, they are considered to be odd numbers. And I'm gonna use this as an example. I'm gonna refer to the idea that n, it could be any integer, okay, integer number. When I say integer, it means that it could be anything as negative or positive whole number, okay? It could be 2, 4, minus 2, minus 3, okay, etc. So I'm gonna consider n as an integer number. When we talk about the even numbers always we jump from a number to another by 2, as you can see, okay? So the concept that I'm trying to explain to you, that proving, 2, one of the things that you might use, that 2n is the general form for describing any even number. While for the odd numbers, if you focus with me here, the odd numbers, they jump also by 2 with only one concept I needed to keep in mind. If I say that, let's say for an example, I'm gonna pick 2 as a number. I would say that 2 is equal to n, okay? You will notice that the 2n is actually equal to 4. I cannot say that I can describe the odd numbers as 2n as well, even despite the fact that they increase by 2. I can do one thing. I can say that this 4 can be 5 if I added 1 to it. So the idea is that I can describe the 5 as what? As 2n plus 1, which is the thing that I'm going to use here. So the other thing that you need to keep in mind, that 2n plus 1 is actually the general form for describing any odd number. And we're going to use this in our advantage here as we prove the prove this algebraically. So the question is asking you that any two numbers, okay? When I say prove that the product of any two numbers is always odd. So I'm gonna say that I have A. I will say A is the first odd number that I'm gonna pick. I'm gonna assume that A is odd, and B is gonna be the second odd number that I'm trying to prove that they can be resulted as an odd number. So the idea right now is to prove what? To prove that the multiplication of two odd numbers is always an odd number. So if I say that the first one, the A can be described in terms of what? If you remember, we said that this is my general form, right? 2n plus 1. So I can say that the first number can be described in this form. It could be described in the form of 2a plus 1. While I can describe the second one, my other number, the other odd number, by the way, keep that in mind, as 2b plus 1. You understand the idea? It means if I say that this number is equal, for an example, 3, and this is equal to 5, here, as you can see, 2 by 3 is going to be 7. This one is going to be 7, and this one is going to be 11. Do you understand the idea? So what I'm trying to teach you is to understand that the general form of any even number, odd number, sorry, is equal to 2a or 2b, wherever is the variable, plus 1. So right now we are trying to prove that the multiplication, the product of these two, is going to be resulting an odd number. So we are trying to prove that the 2a multiplied plus 1 multiplied by 2b plus 1 is going to result an odd number. We're trying to prove that. So step by step now, we're going to try to do, as you can see, we're going to do expanding from our study. So we're going to expand the variables that you see in front of you. So the 2a multiplied by the 2b is going to result 4. It's going to result 4ab, 2a plus 2a plus 2b plus 1 equal, we don't know what is it because we're trying to prove that it's odd. So now what you see in front of you is going to be represented as algebraic expression, and we're going to try to do right now, we're going to factorize to see what we can get. So if we factorize it, using 2, as you can see, if I say 2 could be 2ab plus a plus b, close the bracket, equal plus 1. Now what you see in front of you here is actually representing what? We still don't know. As you can see here, the expression is getting closer to what we are trying to prove, if you understand what I'm trying to say. This is referred to as the general form of odd numbers. We use the letter to use as an example of any integer number. So right now, as you can see here, this is the only difference is that this is the value. So here we're talking about n, as you can see, and here we're talking about 2ab plus ab. The idea is that if the result of this, if it is an integer, it means that all of this could be equal to an odd number. So think about it as I said, if you remember at the beginning, I said that think of it as a equal to 3 and b is equal to 5. And see what you can get here. You'll notice that you're going to get 2 multiplied by 3 by 5 is going to be 15. 15 by 2 is going to be equal to 30. Plus what? Plus 3 plus 5. And when you add all of these together, you're going to get 38. Okay? 38 is also an integer, right? So the idea right now, this form can be, I'm using 38 as an example, by the way. So 2 multiplied by 38 plus 1 is going to be equal to what? 38 by 2 is going to be 6. And you're going to have 76 plus 1, and it's going to be equal to 77. What is the meaning of all of this? After this calculation that I proved that this is equal to an odd number. The idea is that after writing this expression, because this is the ideal answer in the past paper, you should say that 2 multiplied, you say that 2ab plus a plus b is an integer, and since it's an integer, it means that 2 multiplied in, integer, I can assume that another thing to explain it to you, assume is going to be equal to C, for an example. So the expression now, we're going to say that's going to be equal to 2 multiplied in C plus 1, right? And this is considered as an equation 1, and this is as equation 2. You will notice that 2n plus 1 is equal to 2c plus 1 because both n and c are integers. So theory has been proven. That's the idea, okay? Nothing special about solving this problem. It's just about how to understand how you can describe the general form of an odd number. So that's it. I hope that it's clear to you. If you have any questions, let me know. Take care. That was the end of the recording.